Welcome to Brain Vision.
So here it wants us to derive an equation for angular acceleration without solving for time. So we can say our initial angular velocity will be 12.0 radians per second. Our final angular velocity is going to be 16 radians per second. And then our change in angular displacement will be 7 radians. So we can first start off by saying omega f equals omega I plus alpha t, and then we can say angular displacement equals initial angular displacement plus omega initial t plus half alpha t squared. And theta final minus theta initial is simply going to equal delta theta. And then here we can we're going to square this term. So if we squared this term, this equation rather, we would have omega final squared equals omega initial squared plus alpha squared times squared plus 2 alpha initial omega initial alpha t. So that would be this equation squared. And then what we're seeing here is that we can actually factor out a 2 alpha. So we can say omega final squared equals omega initial squared plus we can say 2 alpha, which will leave us with 1 over 2 alpha t squared plus omega initial t. And this is going to equal this. So we can say that omega initial initial squared plus 2 alpha times delta theta will equal our final omega squared. And at this point, we have eliminated time, so we can just solve for the angular acceleration and say that alpha equals omega final squared minus omega initial squared divided by 2 times delta theta. This is going to be 16 squared minus 12 squared all over 2 times 7 radians. And this is going to be plus 8 radians per second squared. So this will be our angular acceleration without solving for time. And that's the end of the solution. Thank you for watching.